a great pleasure coming to you guys, and also for me a strange experience, coming back to an IIT together with an old IITian, Ramesh Venkateshwaran. We were good friends at IIT Bombay, but in different hostels. I was in hostel 3 and he was in hostel 7. And the hostels were pretty much islands where you spent your evenings together, etc. But nevertheless, since we were in the same department, we kept close tabs with each other. And he and I both being Tamilians, it was also an easy connect culturally. So there's one bit of caution I need to exercise whenever I meet him, especially in front of such a large crowd, that I don't delve into old habits of calling him Ennada, Poda, Vada or something like that. He's a very respected person. So, and reverse is also true. He also needs to address me in front of you guys in a reasonable manner, which we typically didn't do at that time 55 years back. Second thing that I want to note at this point is it's pretty amazing for me that you guys can pronounce my name, Balasubramanian. In the last 55 years, no one has been able to do it. When I went to Germany, they all gave up. They call me Professor Bharat. In USA, it's even worse. They can't even say Bharat properly, so they call me Dr. B. So if you go to USA and ask who's Dr. B, that's me. Yeah, that's the code name, and I'm so glad that someone's at least able to pronounce my last name correctly. That said, today I'll be talking about these 3 topics, connected, automated, and electric vehicles, and this was the agenda as Ramesh and you said, that I had changed and transformed the company in 2006. And imagine this is 18 years ago where I predicted that these were the 3 main thrusts that the automotive industry would see and which would probably revolutionize the transportation by the time you guys grow old. One of the things that I tell my students is drive now, because 30 years down the line you might not be allowed to drive. Someone else will be doing the driving for you, a robo-car. So I'll explain to you why this scenario is probably not in India anytime soon because of our rather challenging traffic conditions, but in the Western countries like Germany or USA, very probable. So connected, automated electric vehicles. When you look at this, the 4 main trends, I say connected, automated, electric, because that's the way all the federal calls are put up, CAE. It's easier to pronounce. Some call it ACE, automated, connected, electric. But the basic thing that you need to understand is electrification of the powertrain is a technology today. And you see it happening everywhere. And as Ramesh Venkateshwaran said, that is our legacy project at IIT Bombay, which I'll be heading, where we are setting up a EV powertrain lab for 2- and 3-wheelers. That's today. Connectivity is the new future, which you will need as an underlying technology for self-driving cars. Then safety and automated driving, the safety part and the automated part are 2 sides of the same coin. The safety part is the near future. The automated part, full self-driving at level 4 and 5, that is the future. And finally, the question of robo-cars, shared mobility services, that will be the far future. So let's start with electric cars. There's a worldwide tightening of greenhouse gas emissions everywhere in the world. There's not a single country which does not have very increasing restrictions on the fuel economy, be it the USA, with mileages of 55.3 miles per gallon. That's tremendously challenging. That's like 20 kilometers per liter in a large size car. Then the EU with a target of 70 to 80 grams CO2. And China also, based on the footprint, very challenging fuel economy standards. What goes hand in hand is also the emissions. And the emissions from EPA, from CARB, California Air Resources Board, they are also increasingly becoming stringent. And finally, there are some cities, especially like London, which demand local emission-free transportation. So all this leads to a need for improving the internal combustion engines. Now the IC engine is going to stay with us probably for another 50 years, especially heavy duty diesels for transportation, surface transportation, railroad transportation, marine diesels, etc. And there are various ways of improving the engines, and this is all coming to India. So every new generation of engines you see, you'll have the downsizing of engines, higher compression ratio, variable valve timing and lift, lean burn, etc. Then you'll also see electrification of the ancillary drives. Today, if you look into your car, probably the radiator fan motor is electrified, but most other things in Indian cars are still mechanically belt driven. In tomorrow's car, everything will be electrified, electric power steering, electric high pressure pump, HVAC compressor, oil pump, etc., and shifting to 48 volts. So currently all our cars today operate at 12 volts. The newer cars from Mercedes, BMW, Audi, they all have a 48 volt system. So this shows one of the newer engines from Mercedes, a 6-cylinder engine with the 48 volt system. And what you see here are some interesting parts. The HVAC compressor here is a 48 volt HVAC compressor. So you don't need the engine running to have HVAC. You can see it also here, another view. The supercharger is an electrically driven supercharger. So 48 volts, and it's pretty fantastic. You know, it can go from 0 to 100,000 RPM in about half a second. So it really boosts the power. Besides the supercharger, there's a normal turbocharger, which you can see here. Then the power steering is electric. The water pump here is also electric. So the only thing that is mechanically driven in this car is the oil pump, engine oil pump. That's a long tradition. You know, engine oil pumps work well. Without the oil pump running, you have a catastrophic failure of the engine. And for some reason, all car companies decided we are going to keep it mechanical. But everything else is electric. And you notice here, the engine has no fan belt. There's no more need for a fan belt because on the flywheel side, you mount a starter generator. So it's a 10 kilowatt three-phase motor, which generates electricity. It can be used for regen braking, and it is also a starter. And it's a fantastic starter. If you sit in these cars and you start the car, boy, it's mind-boggling because in about 100 milliseconds, the engine has fired. And the starter is so powerful, it can pull the car while starting. So that's the ultimate of what you're going to see in IC engines. And in the future, this will be frozen. There'll only be minor changes to it. What will come is more and more hybridization. So various levels from micro, mild, and where the industry is going now, and Toyota pioneered this with the Prius, is going into plug-in hybrids. So if you see today's cars at Mercedes and BMW and all, every model is now offered either as a gas engine, petrol engine, or as a plug-in hybrid. And in a plug-in hybrid, you have a battery capacity of 20 to 30 kilowatt hours and a range of about 100 kilometers. So you can do your daily commute in a full electric mode, and at home, you would recharge every night. So 5 days a week, you would have full electric operation. And then over the weekend, if you drive to Coimbatore, you would do partially with the gas engine and partially with the electric motor. Range extenders were tried, and basically it's a series connection. You have the petrol engine driving a generator, supplying a bit of power to the battery and supplying power to the electric motor to drive the wheels. This is an old concept. All the railroad diesels that you see in India and the US, they have this concept. So the GM diesel that you see here of EMD, the diesel motor runs an alternator, the current is rectified, it is inverted and drives 6 traction motors, AC traction motors. It's not very popular because it has a lot of losses. Then the last two, battery electric vehicles and fuel cell electric vehicles, this was a lot of challenges. In the early 90s to 2000, Daimler-Benz was very vested in fuel cells, And when I became head of research, I was very vested in electric cars. And my talk to the CEO was, electric cars are much more viable than fuel cell cars. With fuel cell cars, you need the stack, and the fuel cell stack is an extremely complex and expensive piece of equipment. But all the other components are the same. A fuel cell electric car has the electric motor, the inverter, and a buffering high voltage battery pack. And these are the only three things you need. And we were far advanced compared to the world because we had a lot of knowledge on fuel cells. So my contribution at Daimler was, let's go for electric cars. And that's where Ramesh said I collaborated with Silicon Valley. And this is where the future is moving today in all over the world. Now you might be of different opinions whether the electric car is really the right solution, especially for long distance, the lack of infrastructure or the necessity for fast charging infrastructure, but that will all get resolved and there is no going back. If you look at the US, Europe, especially China, and with China, they did a strategic decision. They said they cannot overtake the Western world in IC engines, so they concentrated on battery electric vehicles. And today, China is far ahead of everyone else. More than half of the world's battery packs come from China. All the Mercedes-Benz battery packs come from China. And this is all very scary because your future is being determined by a partner who might not be very positive to you, depending on how he interacts with your nation. Fuel cell, it's still an option. It'll be an option for heavy-duty trucks. But if they don't get their act together, it'll lose out to battery electric vehicles. That said, consequences. Now, this is part of the big game changer. If you look at this shift from traditional mechanical manufacturing to electrical electronic manufacturing, the IC engine has many hundreds of mechanical parts which have to be designed, manufactured, and assembled. The electric motor has only a few parts. It's the rotor, the stator, the housing, and the bearings. Extremely simple. There's no high tech. And this is also very interesting if I talk to younger people, you know. If you look at a Mercedes AMG or a Porsche, the sound of the engine determines the character of the car. So you can say my Porsche has a 6-cylinder engine, and I can say my Mercedes has a V8, and someone else will say my Bugatti has a V12. Tomorrow, if you have an electric motor, what can you say? My motor is a 12-pole motor or a 24-pole motor. Who cares? Who cares? More importantly, all you guys who are studying electrical engineering know that the efficiency maps, the power maps, they are near identical. You can measure different electric motors near identical. And ultimately, whether you build in a Mercedes motor or a Siemens or a Hitachi motor, who cares? So one part of brand identification is lost because you're shifting into electric motors. And it's very interesting with Tesla. Tesla's electric motor did not come from Tesla. It came from a company called AC Propulsion, which still exists. AC Propulsion designed the motor, manufactured it, as also the inverter. Tesla's big game changer was the battery pack and the battery management system. Power electronics, ECU and inverter, this is something that the automotive supplier will manufacture and where the OEM, Mercedes, Fiat, or whoever else, will program. Finally, the differentiator is going to be the high voltage battery. The cell manufacturing per se is a tier 2, tier 3. Tier 0 is the OEM. Tier 1 are the big suppliers, Bosch, Continental, Delphi, etc. Tier 2, tier 3 are the smaller suppliers. So cell manufacturing is a tier 2, tier 3 competency. Battery packs, cooling, safety, battery management system, that would be a competency of the OEM. So every OEM tries to do the battery pack design, especially the thermal management, the battery management system, keep it within his company and have control over it. So if you look at the impact discussion, electric motor, whether you manufacture in-house or not, it's primarily a decision forced by I have too many people on the IC engine manufacturing, and I need to transform part of them for electric motor manufacturing. If you don't have it, then you don't care. You just buy the electric motor from big supplier like Siemens or Hitachi. There's not much assembly required. The transmission, today most cars have automatic transmissions in the Western world. We started with 4, that's where I started my life, 4-speed, 5-speed, 6-speed. Today, ZF offers 8-speed, Mercedes offers 9-speed, and GM Ford offers 10-speed. And that's the end of the line. And if you look at the maps, you would question why do we need 10-speed? Because the new IC engines, they're so good efficiency range over the entire load and RPM that you basically can do well with a 3-speed. But electric motors need only a single stage reduction. And that single stage reduction is to keep the motor small and running at high speeds, and to get it down to the wheel speed. Wheel speeds are typically about 1000 RPM in most countries, other than on the German Autobahn where you would need 2000 RPM to do at 250 kilometers per hour, but about 120 kilometers per hour, 1000 RPM. You run the motor at 5000 RPM, so you have a 5:1 reduction. Pretty straightforward, nothing new, but it's an interesting story there. The first Tesla, they had tremendous problems with the gearbox. The single stage reduction, I think high school students designed the transmission and the bearings and they all failed. So they had to recall all the Tesla Roadsters. Then the inverter is going to be a tier 1, tier 2, or it's going to be a commodity. What's a commodity? It's something you buy off the shelf, like soap or dishwasher detergent, etc. There's no differentiator in that. So this is all going to impact the automotive industry. The only thing that can become a differentiator is the battery pack. Yeah? And the cell manufacturing, multiple companies tried to get into it, OEMs, they just did not have the knowledge. And today, the world's largest cell manufacturers are all in China, followed by Korea. That's it. It's very interesting. It's not in Western Europe, it's not in USA, etc. Electric motors, a lot of challenges with rare earths because we run 3-phase permanent magnet motors. And in the earlier years, they were asynchronous motors. So you see 3-phase asynchronous motors on all the railway diesels. They do not have the efficiency range that permanent magnet synchronous motors have. A very, very interesting technology which has caught on and which is now standard in all cars. 3-phase motors with very similar, near identical characteristics. Cell materials require a lot of basic materials and precursors, and very few countries have these, and so you are very dependent on them if you want to start manufacturing cells. And there's one thing about electric motors, etc., and Ramesh can confirm this. We had a guy called Professor Kamath who taught us electric motors at IIT. He was the most difficult professor. Now, we are also professors. We think we are always very kind to you students. At least we believe that. In reality, what you say behind our backs is unknown, but probably you think we are also tough professors. But Kamath taught us electric motors, and his exam papers were mind-bogglingly difficult. Yeah? None of us could get an A in that. And today, if there's one thing I regret that I did not work hard enough in his class, because all the things that I'm doing there are related to what he taught us on electric motor controls. And it has become the game changer for many companies. So looking at cells, which is the real value add, this is a chart that I pulled up from the Department of Energy. If you look at all the companies and what they are planning to do on battery manufacturing, cell manufacturing and pack manufacturing, look at all their partners. SK Innovation is a Korean company. LG Chem, LG Energy, Korean company. Samsung, Korean company. Only Koreans, no Chinese, because the Chinese are not willing to collaborate. Yeah, so very tough equation. And now we are putting all your eggs in one basket. It's the Koreans. And there is one Japanese company also. and these are the places where they are putting up their plants. I live near Atlanta in Tuscaloosa. So tremendous activity on self-manufacturing in the United States and building the battery packs and controlling them. Next one is the connectivity part. Connectivity has multiple aspects. It's the way our lifestyle has been set up, the Internet of Things, where you have your smartphone and you want to seamlessly transform your lifestyle with the smartphone when you're driving in the car. So it means integration of your smartphone functions into the vehicle. At Mercedes, we developed our own solution in 1997. It was called MB Command, and it was fully integrated into the vehicle, where you could access most of the functions safely through a terminal through a screen using in-vehicle controls. It took a lot of time till Apple came up with CarPlay and Google with Android. Today, these are the more favorable solutions in entry-level cars. And if you look at the reason for people buying cars today in the United States, if there's no Apple CarPlay or Android, they will not buy the car. So it has become a game changer because they want full integration of their smartphone and their lifestyle when they're driving a car. Going to be very challenging because we believed, Mercedes-Benz, if you integrated it fully, you have a uniform and consistent user access with all functions of the vehicle. And this Apple CarPlay introduces certain functions which you see here, the phone, the music, navigation, etc., but not all functions. So it is a bit disparate. So what is Apple thinking about? And this is the future of Internet of Things. They say, let us supply the entire dashboard. So this is from an Apple video where they will offer you not only the Apple CarPlay, but the entire dashboard. They will connect to your CAN bus and show it to you. Now, there are a lot of companies who will say, boy, that's pretty cool. I don't have to put in R&D effort. Someone else will do the R&D for me, and they will generate a cool interface, and they will validate it, and they will offer updates every few months or years. So, takes a load off me, but you have given up part of your brand identity. If you get into a high-level car, the first thing you see is the dashboard and how the instruments are presented. So that also disappears. Another part of brand differentiation is gone because someone else is going to take it up. Where does this lead? Let me go into the other part. That was the Internet of Things. The more important point is connectivity. Connectivity is where you set up connections between the vehicles and between the infrastructure and the vehicles. And we use it, and you would need it when you go into self-driving cars. Silicon Valley will never tell you that, and Tesla also doesn't tell you that, but a level 3, level 4 driving needs connectivity. In the earlier stages, we did it with a technology called dedicated short-range communication. It's in the 5.9 gigahertz range, a dedicated range, and as against a cell phone. In a cell phone, you dial another number, or when you do an internet session, you dial an address, and that gets downloaded to you. So it's a point-to-point communication. With DSRC or cellular V2X, it's an ad hoc communication. You sit somewhere in your car, you communicate, all other vehicles in the vicinity listen to it, and if that message is relevant to them, they act upon it. And these are basic safety messages, or it could be signal phasing and timing, and there are a lot of cool applications which can come with connectivity. Now, initially DSRC was a standard which was defined and accepted in the United States, but no one was willing to put the money into DSRC. If you use DSRC or cellular V2X, you need to have infrastructure at least 1 kilometer so that the vehicle can communicate to the infrastructure and then from the infrastructure to other areas. What is the other big difference to normal cellular connections? The latency times. Normally, when you set up a phone connection, it takes you about 1 to 3 seconds to build up the connection. In India, it takes sometimes 5 to 10 seconds. Here, you need 100 milliseconds because these are safety messages. So let me show you 2 films of how connectivity would be used. The first scenario is an emergency vehicle. And typically, when an emergency vehicle, you hear it, you cannot place it. In which direction is it coming? And do you make way for it or not? And with connectivity, the vehicle would send messages. All the vehicles in the vicinity would get this message. Also, the location from which it is coming, you would move over. As also, when you come to an intersection, the traffic signals through connectivity from the vehicle to the infrastructure would automatically switch to green for the emergency vehicle and red for all other directions. So that's the movie here. So it's sending out these connectivity messages. On your dash, you will get this message here. You will make way for the vehicles. When it comes to an intersection, the lights will shift to green for this vehicle and all other lights will be switched to red. And the big advantage of this is all local. It's some probably a radius of 500 meters and everything else is left the way it is. So very powerful technology which you would also need with self-driving cars. One of the biggest challenges with the Google and other cars is they can't recognize an emergency vehicle. They can't recognize a fire truck. Yeah. And the reverse is also true. There have been so many accidents with the Tesla and the GM Cruise where a fire truck has been parked on the road and this vehicle did not expect it and crashed into it. Yeah. Second area, when you have road conditions where one vehicle goes into a skid, you want to tell all other road users to be cautious at that point, which you again need for a self-driving car because a self-driving car doesn't know that the road is icy or has rain on it. So this is probe data collection.
ESRC technology makes it possible to automate traffic and roadway status updates from a large number of probe vehicles over the entire local road system. More detailed and localized information can be routinely collected. Beyond just traffic movement information, a probe vehicle could also use DSRC to report dangerous road conditions such as traction loss. The control center is able to identify problems quickly as it receives and coordinates a number of reports from the same location. It can then alert approaching traffic through in-vehicle or roadside messages.
And these are some of the things you would need when you are in a self-driving vehicle. Snowy road, rain condition, construction zones, etc. And vehicle to infrastructure information would be passed on and support upfront information of a self-driving car. So what is the consequence? On the infotainment side, the loss of customer interface. You know, if you have Android, Google Android, or if you have Apple CarPlay, you have lost out because the interface now is with the provider, Apple or Google, and they'll analyze everything that you're doing and they'll make you offers. Yeah. Then shift from hard connected software updates to over-the-air software updates. The smartphones become the infotainment hub. OEMs do the low quality work. They provide the display, amplifier, and loudspeaker. That's it. Yeah. The high-end work is done by someone else. So again, you lose your brand identification. And in the procurement discussion, the navigation, user interface, etc., they're all external guys. Yeah. If you look at navigation, very few people today are willing to buy in-car navigation because they say, I already have my Google navigation on my smartphone. I'll just connect it to the head unit and that's enough for me. Yeah. Then there are subscription models where companies, car companies, as also the smartphone companies are competing with each other. In the subscription models, once you have an electric car, you need to subscribe to the OEM because he has a lot of knowledge on which charging stations are free, how is your state of charge, what range can you have with the state of charge, when do you really need to recharge the vehicle, etc. So all car companies offer you some sort of subscription model once you go into electric vehicles. If tactically advantageous, smartphone companies will offer you free subscription. But whenever you get something free, there'll be intrusive data mining. And I'll come to this in the self-driving software. If you look at your own habits, including mine, anytime you use Google Search is looking at you and trying to analyze your behavior. Anytime you use email from Google or you use the Apple smartphone, it's always looking at it and reading your emails. So if I get an email from Lufthansa telling me a flight change, Apple gives me that information, asks me, shall I update your calendar? So it's reading my emails. If I go into Amazon and look for some product, at once I get a feed on Instagram and Facebook offering me the same things. So all our data privacy is going away. Luckily, I'm so old now, 72, I say, okay, I'll go to the grave with this, but you guys need to find solutions because in another 10 years, the system will know more about you than you or your parents or your siblings or whatever else will know about you because of intrusive data mining. And this is a model that Silicon Valley has picked up and has become the basis of their model. So the impact discussion, the infotainment functions will be split between OEM Tier 1 and the smartphone supplier. Customers of premium vehicles, so Mercedes-Benz S-Class or a BMW 7 Series, we will prefer in-vehicle integrated solutions. All others would prefer the smartphone solution. There's an increase in electronic hardware manufacturing, dramatic increase in software and app development, especially through non-automotive suppliers. The last and third area is the evolution of safety and self-driving. Why do I talk about safety? Because if you have a self-driving vehicle, it has to be safe. And you can approach this self-driving vehicles through two areas. Traditional automotive companies, we always approached it to the safety. Silicon Valley, like Tesla, like Google, approached it from the self-driving side and tried to take care of the safety side on the fly. If you look at the safety side, these are some of the innovations that most of your cars would have. On the top, the reactive systems, you have this in all your cars in India, rigid passenger cell, 3-point seat belt, anti-lock braking systems, airbags, electronic stability control. And on the right, you see who invented them with which supplier. Those are reactive systems. Reactive systems imply something has to happen for the system to deploy. When we introduced, and my group introduced long-range radar, and that's the basis of adaptive cruise control and blind spot monitoring today, in 1998 in the S-Class. And what does radar do? Radar sends signals at 77 gigahertz. Signals are reflected. So from that, you can judge the distance to the vehicle in front and the closing speed. And that is needed for maintaining a safe distance in what we call adaptive cruise control. Short-range radar, as the name suggests, became universal in all directions. So we put 4 short-range radars at the 4 corners of the vehicle. And with that, you had a very powerful safety aspects, so things like blind spot monitoring, no lane change if there's another vehicle in the other lane, etc. Then the stereo multipurpose camera, and that was my last piece of work in 2012. And finally, now in 2021, the first LiDAR that we have introduced in the S-Class, which has level 3 driving, and I'll explain to you what that is. Whatever I write here, these are automotive grade. So if you look at the LiDAR, some of you have seen the Uber and Google cars with the rotating Velodyne LiDAR. That doesn't last. It's good for a prototype, but that's it. If a bird hits it, it's all gone. If it's rain, it's gone, etc. Now, whatever you put here, these are products you can buy, which are rated for 300,000 kilometers, 20 to 30 years lifetime, etc. So this is the real thing. Safety systems, dramatic changes coming from reactive systems to proactive systems. So in the proactive systems here, with the radar and the camera, with the camera today I can do evasive maneuvers. So if it detects a pedestrian or a vehicle crossing my path, I can do automated braking, or the vehicle will do automated braking, or it can do an evasion maneuver. So it is a proactive system. It will try to avoid an accident or mitigate the consequences of an accident. What we do is we fusion the signals for high quality traffic and vehicle situation. And there are a lot of signals coming from the cameras, from the short range radar, from the medium range, from the long range radar, etc. And there's one important point. When I discussed this with Elon Musk, and I predicted to him at that time that electric cars are not the coolest thing, it's self-driving cars. And today, if you look at the value proposition of Tesla, it's always self-driving. Forget the electric part. Who cares about the electric part? Because everyone is offering electric cars. And the self-driving cars, we were of the same opinion that cameras would do it all. But my group convinced me that cameras still don't have the power and ability to match the closing speed, closing distances, the way the radars can do. My feeling, and Tesla, Elon also said the same, we believe the human eye, our entire driving is done through our eyes, through nothing else. And that's the reason for the stereo camera. Stereo camera means two cameras, and through the lateral dispersion, if you close one eye and look at an object, and close the other eye and look at the object, you have a lateral disparity. And that's how the human brain builds the distance to you and where you are positioned. And that's what you try to program into the camera. And so Elon went gung-ho on this. If you look at the Tesla today, it has about 20 cameras all over. But the rest of the industry remained with radar because radar is much more powerful in detecting metallic objects safely, and we fusion these signals for high quality traffic and vehicle situation analysis. Now the main advantage of all these sensors is extreme societal benefit because they prevent accidents. Yeah. But at the same time, they can be used for self-driving. The same sensors, the same actuators, slightly different software. So if you look at self-driving, the SAE has set up levels of self-driving which is used universally in the world. You don't have to read all the fine print. They have 5 levels. Level 0, all sensors on. Level 1, your feet off the pedals. So that's adaptive cruise control. You don't have to brake. You don't have to press the throttle. The vehicle maintains a safe distance to the vehicle in front or maintains a safe speed to the vehicles in front. Then level 2, you have lane keeping. So the steering is taken control of. And this is the current state of the art in most of the cars today which are offered. And it's very relaxing to drive. You are not allowed to take your hands off. There's a hands-on detection to keep you in the loop. Level 3 is where the major change is going to happen, and it's happening anytime now, where your eyes can be off the road. The moment your eyes are off the road, you can start reading a book, you can work on your computer, you can watch a movie. There's only one level 3 car certified in the world today, that's the Mercedes S-Class. In Europe, and now starting this last year, fall, in some states in United States. So in California, Arizona, Nevada, with a LiDAR sensor. And that's really eyes off the road. Level 4 is brain off. With level 3, if the car comes to an ambiguous situation, it needs to put you back in the loop. So you have to be in the driver's seat, ready to pick up and drive the car should it come into an ambiguous situation. In level 4, with brain off, you can sleep. You can go and sit in the back seat and relax. And if the car encounters an ambiguous situation, it needs to search for a safe harbor, stop there, wake you up, and then you have to take control. If you don't wake up, it'll just stop there. Level 5 is body out. That's the robo car. Now, companies like Uber, they're going for level 5 because that's their business model. Remove the driver, use the car, it'll come and pick you up and it'll drop you off. And it's all pretty fantastic. And it's working in prototype manner and it's mind-bogglingly scary. So where are automotive companies? Most of us are here. Mercedes is the only level 3 car that you can buy in the S-Class today. Google is somewhere here. Uber tried to be here but has stepped back and sold off its unit. GM Cruise also sold off its unit. So the only real competitor today is Google at level 4. So let me show you level 2 in my car driving on an American highway from Alabama to Kentucky, driving at 70 miles per hour, and my hands are off the steering, and I'm filming myself. So my hands are not on the steering. The system always complains after 10 seconds if I don't put my hands on the steering. It takes the curves without any problems. 70 miles per hour is about 110 kilometers per hour. So it's again asking me to put my hands on the steering every 10 seconds. If I don't put my hands on the steering, after it warns me, it disengages. And then the safety systems take over. So here's the right curve. And I've not put my hands on the steering now. So it's telling me to put my hands back. I don't do it. The car starts wandering away. Then ESP kicks in, the safety system, and pushes me back into the lane. So here is the philosophy that automotive manufacturers have. If there's a dangerous situation, the same sensors and actuators take over and bring your car into a safe position. This was lane keeping. It could also be braking. If the vehicle in front brakes, or if there's a strange object on the road, the vehicle will brake autonomously. So the safety systems kick in and protect you. And basically, it's the same hardware, same sensors, actuators, but slightly different, differentiating software. So the software we write in such a way that anytime there's a safety situation, this takes precedence over self-driving and brings the car into a safe mode and then hands over control to you. The big challenge here is to safely hand back control to the driver, especially at level 3. So what is the solution that Mercedes offers today? It offers you 10 seconds to take control. In those 10 seconds, Mercedes takes over the liability of a crash. So 10 seconds is a long time. If you're reading a book or working on your laptop, you have time to close the laptop, chuck it aside, and take control of the vehicle, etc. Silicon Valley says this is not possible. So we'll go straight for level 4 or level 5. Let me show you, before I retired in 2012, we said, let's try to do a level 5 or level 4 self-driving on real roads. So we converted an S-Class with sensors. All the people you see in the movie were my engineers.
We wanted to find out what it takes to make a vehicle move itself autonomously in regular traffic. So we said, let's go and check it out. On about 100 kilometers of country and city roads. With technology that is actually not that far away from what's in the S-Class already today. We did not just pick any route, but a very special one. The route we're Mercedes-Benz made history 125 years ago with the world's first overland drive.
The challenges were enormous. From the smallest streets and little villages to big cities, we had everything.
Common navigation systems are not precise enough. We needed a localization that can give us the exact position on a centimeter base. With cameras, we matched the surrounding with data in our map 10 times a second.
Each traffic light has to be correctly identified under all weather and lighting conditions.
The sensor system not only have to identify all the traffic, they have to predict the movement.
We must teach the vehicle to take the right decisions in all situations, reliable and within fractions per second.
Of course, it's a research project and it's still a long way to serial production. But with this project, we definitely took a big step forward.
The two people who invented the car today were Gottlieb Daimler, who had his workshop in Stuttgart, where I have one home, and Karl Benz, who had his workshop in Mannheim and studied in Karlsruhe. And they were fierce competitors and never collaborated with each other. There's an interesting story that Karl Benz's wife, one day, without his knowledge, took the vehicle and drove this 100 kilometers from Mannheim to Pforzheim. And this is all pretty incredible. Imagine that was a world where no one knew of a car. There were no roads, no gas stations. The concept of a combustion engine powering a vehicle was unknown. There were only horse carriages, horses, mules, etc. No roads, only paths. And this lady, for whatever reason, she did that drive. There is no historical record of what Mr. Benz thought or how angry he was to find his vehicle missing. But this is a true story and speaks pretty much for the bravery of Mrs. Benz to take the vehicle. And that's why we did this same route that she had done. Pforzheim is about 50 kilometers from Stuttgart. Moving forward, this is a movie from Google, August 6, 2022, Waymo self-driving.
So it's inching forward, and it's turning right.
Full self-driving. Driver sitting in the back seat.
Just keep seeing the traffic coming. And then finally goes. So what we'll take unprotected lefts, it will take red on red. The only thing it won't do is speed. It goes exactly the speed limit. Alright, here is our Waymo autonomous car. It says JG on the front, which you can barely read because it's an LED. You got LiDAR sensors there, LiDAR sensor on the front, another one here.
Or rotating lights.
On that, door opens. Couple of seats.
This car is all yours with no one up front.
So, hop in. No one in the driver's seat. Alright, so what we'll do, first, start riding. Off we go. And so the screen shows you everything that's around you and what the car sees. Ooh, a little jerky here, a little shaky. So it shows that car. We're going to go right. Come here, out of parking lot.
So I'll move to the end of the movie. So he drove to Marriott Courtyard.
Smoothest stop, but it got the job done. Thanks for running Waymo.
Yes. Today, pretty pretty impressive.
And so real quick, just a quick show in here, we have this.
Pretty impressive. But we have the advantage, the human brain, of many 10,000s of years of evolution. And in edge cases, we as humans perform better than these vehicles. And that's the challenge, to get all the edge cases resolved, which we as humans do through intuition and experience. So what are the consequences? This is going to be the most disruptive technology. Drone technologies and automated driving will converge. Level 3 automation will lead to higher transportation efficiency. So the trucking industry is all for it. And my prediction is, on American highways, you can do level 3 driving for long stretches because the highways speed differentials are low, no pedestrian traffic, no cross traffic, no traffic lights, multiple lanes. So if you want to travel 2,000 or 3,000 kilometers, you can do it in full self-driving mode. And that would dramatically increase efficiencies. That's the reason Silicon Valley companies are investing heavily in these technologies, but their motivations are totally different from normal car companies. When we develop new technology, we offer it as an option. We charge you $1,000 or $2,000 more for that option. And later on, we price it into the vehicle, and all the lower level models also get it. With the Google model, it's the search engine email model. Offer it free. You get self-driving software for free. But what you pay is you sell your soul to the car company. It will interpret everything. Today, if you look at Apple or Google, they read your emails, but they don't read your WhatsApp messages because that's encrypted. They don't read your photos. Tomorrow, when Google offers you this, it'll upload everything on your smartphone. Your photos, your pictures, the messages you exchange with your partner, with your children, everything. And they'll use the big data analytics and artificial intelligence to build a holistic model of you. Who are you? Who's your partner? Who are your parents? When did they fall ill? Where do they live? What did you buy them 20 years back? Where did you go to school? Who are your friends? And with that, they will monetize it. So they look at you and say, okay, 2 years ago or 5 years ago, you bought a car. Probably you would like a new car. They'll sell your address to a car company, and the car company will contact you and say, 5-year-old car, why don't you try a new one? We have a new model. They'll monetize it. That is their model. So basically, we are already starting to sell our souls because we all use Google search, we use Microsoft products, etc., and it'll all be tied into it. And this will be the most intrusive. Because if you look at your smartphone today, we have so much of it. I have my banking apps in it. I have my emails on it. I have my WhatsApp. I have my contacts in China with WeChat. Everything is there. Instagram, Facebook, etc. And everything will be read, uploaded, and through a deep learning model, a uniform picture of you would be set up, and a picture where even your wife will not know you that well because it remembers everything of the last 50 years. If you look at the impact discussion, sensors, they are tier 2 competencies, tier 1 and tier 2 competencies. And there are a lot of cool companies coming up, both in Europe as also in Silicon Valley, which offer the sensors. And basically the sensor you're looking for is LiDAR. The radars have been standardized. Continental, we developed the radars with Continental, cameras with Continental, with Bosch. There's not much new technology. The real new technology is the laser scanners, the LiDARs, and a lot of companies are working on it. Yeah. The ECU, the hardware is dominated by a few companies, NVIDIA, Intel, and Tesla developed. Elon Musk is sometimes so crazy, he says, I'll do my own chip. Mercedes-Benz is currently cooperating with NVIDIA. So Jensen Huang, who's the head of NVIDIA, and My colleague who got me to Alabama, he's the CTO, they are collaborating for self-driving, where NVIDIA develops the chips for self-driving. Intel did the smart thing. It bought over a Israeli company, Mobileye, which was very strong in self-driving. So in the 2006, 2007, when I was head of research, Mobileye and Mercedes were the only two companies which had any technology being offered for self-driving level 1, level 2. Most of the companies used, we used our own technology, and Mobileye sold their technology or offered their technology to Audi, BMW, GM, etc. And Intel bought over Mobileye sometime about 6 years ago. So Intel has got into the game, so they would produce the chips, Mobileye would do the software. Yeah. And sometimes I think, hell, you know, and this is a philosophical discussion in the evening, for the evening. In the German system, including myself, we were just technology driven. Mobileye was technology and business driven. So they sold their company for $15 billion to Intel. If I had had the same knowledge and risk taking, I would be worth about $5 to $10 billion, and I would probably not be standing here talking to you. I would be relaxing somewhere on the beach, drinking my juice or whatever, you know. But this is something I always think about when I see the Intel Mobileye tie-up. So hardware is out of your hand. Software and algorithms, that is the end game between OEMs and Silicon Valley companies. And for me, neither of them can win alone. If Google goes for it alone, they will not win it. If Mercedes goes for it alone, they'll also not win it. So there are a lot of mutually beneficial. The two that I know of, Daimler Truck North America and Google work together, and Mercedes-Benz and NVIDIA work together. So that's the only way you're going to get self-driving technology on the road safely. With shared mobility, I'll just spring over it because shared mobility will follow with self-driving cars, with robo-cars, when level 4 is universally available. So it's a follower technology. It's not going to be very disruptive early on. Let me go back, go forward. So in summary, electric, connected and automated vehicles and car sharing together will disrupt the traditional automotive industry. It will start in the Western world by 2030, and this is very important for educational institutions. 65%, over 60% of the car would be electrical content, software, hardware, ECUs, etc. The rest being mechanical content. We need to refocus our manufacturing strategies to go into cells and it's battery pack manufacturing, because otherwise we will not be able to maintain competition. China is already far ahead of the rest of the world. The workforce strategy needs to refocus software engineers for battery management, connectivity, and automated driving. And our education strategy at the universities need to refocus teaching and research on battery electric vehicles, connectivity, and automated driving. And this is part of the work that I'm doing at the University of Alabama, refocusing on the new areas. So one of the things I did, and I'm sure some of you might not like to hear it, I stopped teaching my internal combustion engines class, because the students I teach, once they pass out and go into industry, there'll not be much work for them other than on the heavy duty diesels. But on light duty vehicles, no car company is going to design a new IC engine in the next 5 years. After that, it's all over. It's just maintenance, preventive maintenance of the vehicle design, but no new designs. It's all shifting over to electric vehicles. Yeah, here are some photos with whom I worked. So that's with Elon Musk. Then this is Tony Fadell. He was the CTO of Apple. He was the guy who invented the smartphone and killed Nokia, etc. Ramesh knows him well because he set up a call with him for IIM Bangalore, where Tony Fadell made some speeches and panel discussions. This is Eric Schmidt. He's the longtime CEO of Google. You also notice one thing. I am always suited and booted, Today is the first day I didn't have a suit on. Ramesh did not tell me that he was going to wear a suit. Hell, last 50 years, every day I've been wearing a suit. For one day I didn't, and he's got a suit on. And this is my proof. Look, here I took off my tie. Yeah, I have my tie. And these guys, you know, there's a standard prediction I make. I am a poor millionaire. A poor millionaire. These guys are all billionaires. If you look at them, this is a normal billionaire, Eric Schmidt, CEO of Google. So he's still decently dressed. Those guys are super billionaires, and Elon Musk is today the richest man in the world. Tony Fadell was at that time probably one of the richest guys. He's wearing a shirt without a vest inside, toned jeans, and what you can't see is sandals. So the mark of a true multi-billionaire. I'll leave it at that. Thank you for listening to me.